All right, we're pretty much done with trigonometry, but we're still going to be using trigonometry in the rest of what we do the rest of the semester. We're going into is actually called conics, and you've already watched a video on how conics are created by taking a plane and slicing what's called a double nape cone, and how you have different ones, such as a circle and an ellipse. A circle is just a special ellipse. You have a parabola, you have a hyperbola. All right, so the first thing we want to talk about is we want to talk about a parabola, and this is just a review from Algebra 2 because you did do this in Algebra 2. So I have my parabola drawn up here, and this is just the parabola that you're used to seeing. This dashed line through the middle, this is actually our axis of symmetry. Now, not so much I'm going to ask you for the axis of symmetry like they did in Algebra 2, because it's going to be all on the same lines. I'm going to be focused on other parts of this conic. Now, this solid line right here, we call this a directrix. Now, if I'm asking for the directrix, you need to give me an equation of a line. Just don't give me a number, because a number isn't on the xy plane, but an equation on a line. So it'll either be an y equals or an x equals. In this case, because it's horizontal, it's going to be y equals something. It never will touch the x-axis unless it is the x-axis. The point right here, this is called your vertex. And your vertex is always going to be h comma k, and that'll make sense in a second when I actually write the standard form of the equation. So your vertex is always h comma k. And then this point right here is called your focus. Your focus is related to your directrix. They're directly related. The reason why is any distance from my focus to the parabola, let's call this d sub 1. And then from my parabola to my directrix, they're the exact same length, d sub 1. This is actually how a parabola would be formed if we just took a piece of paper and started folding. We can actually just draw a line and a dot, and we can fold it over, and we can actually make a parabola with a series of tangent lines. So these are the basic ideas of the parabola and the vocabulary: axis of symmetry, directrix, your vertex, and your focus. And knowing that these are the same distances, it's a nice thing to know, but that's not going to be something I want to test you on. So now let's take a look at the two different styles of parabolas we have, and the general form, and how we can tell which one we have. All right, so we're going to go back to this original one right here with my axis of symmetry, my directrix. We have my vertex. The axis of symmetry, the focus, and the vertex are all going to be on the same line. They're all going to have the same either x or the same y value. Depends on the orientation. Now this one right here, if I wanted the axis of symmetry, it's going to be x equals h. My directrix is going to be a formula y equals k minus p. And you know what I forgot to tell you is I forgot to tell you where p is on these parabolas. P is the distance from your vertex to your directrix, and it's also the exact same distance. This is not drawn to scale, your focus to your vertex. So these distances would be exactly the same. They're evenly. So when I say P, I'm talking about this distance, or this distance, because they're exactly the same. My vertex is h comma k. And now, if you really just think about it, I'm moving up, so that's going to be my y value. So my focus, to find my focus, is going to be h comma k plus p. If you're just thinking about it for it to make sense. Because you're at your k, you're going up p units, is k plus p. So that's how you can find all of these really quick. Now, if p is greater than 0, it opens upward. In this case, my p would be greater than 0. If p is less than 0, it opens downward. So that's how we're going to be able to tell if it's facing up or facing down. Now here's the general formula for this. We're going to have x minus h squared equals 4p y minus k. All right, so here's what's important. As we get into conics, every one of these conic formulas are going to have an h and a k. The h is always with the x, and the k is always with the y. It doesn't matter if I move these around. H is always with the x, K is always with the y. And if you notice with the minus signs, that means we're going to take the opposite sign. So as we do an example, you'll see what I'm talking about, where we're going to take the opposite sign for my h and my k. So this is one orientation. Let's look at the next orientation. All right, so now we have another parabola, but this one's not a function, so you wouldn't be as familiar with it, because in Algebra 2 and even in Algebra 1, when you dealt with parabolas, they were always a function. They had to pass the vertical line test. This one does not pass the vertical line test. It is not a function, but it is still a parabola. This is a parabola that's on its side. Now, we have the same parts. We have the focus, we have the vertex, we have the directrix, we have the axis of symmetry. And this one's actually going to give us, we're going to have formulas for this. To find my directrix, it's going to be x equals h minus p. My axis of symmetry is going to be y equals, just to make sure I get this right, y equals k. My vertex is still h comma k. That is never going to change. But this time, if for the focus, you can just think your way through it once you understand what's going on. This distance is a p, this distance is a p. I'm moving on the x's, so it's going to be h plus p comma k. So if I ask you to label everything, I want to ask you to label the axis of symmetry, the directrix, the vertex, and the focus with the parabola. So we've talked about the upward facing, the downward facing. I'm going to show you the formulas to tell you when this is right facing or left facing. Okay, if P is greater than 0, it is right. It opens right. It opens in the right direction. So here I know that my P is a positive direction because it's opening to the right. But if my P is less than 0, that means it's going to open to the left. Everything else still works the same. It's just going to, you're going to graph it differently. Going to open to the left. And my formula, now you've got to pay attention to what's being squared, is y minus k, because k is always with y, squared equals 4p x minus h. So h is always with x, y is always with k, but now whenever it's on its side, when it's opening left or right, my y value is squared. When it's opening up and down, the x value was squared. That is the subtle difference. So you have to pay attention to where the square is, and you have to pay attention, is my p greater than 0 or less than 0? So the first step is to identify what's being squared. If y is being squared, it opens left or right. Then look at your p value. If your x is being squared, it's opening up or down. Then look at your p value so you get the graph correctly, so you get it oriented correctly. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.